All right, MiniExam 6 demo. This one comes at you replete with creative names and titles. So we're given the demand curve for some firm X. I'm sorry, for a good X. And we have a single seller A. I'm already getting units confused. So A can produce at a constant marginal cost of 10, and we're given the marginal revenue curve here. All prices are in galleons. So the first part of the question asks about equilibrium quantity. So this is a monopoly. We have a downward sloping demand curve. We have our marginal revenue curve. And we have a marginal cost curve. And the way we solve these problems is we intersect MR with MC, find the equilibrium quantity, Q star, then run the quantity up until it hits the demand curve. We're trying to sell everything at the highest price possible. And that gives us our price. So to do this, all we have to do is set MR equal to MC. And we know MR is equal to 100 minus 2QA. And MC is equal to 10. Okay. So then QA, 2QA, and I'm actually going to drop the subscripts here because we don't need them in this part of the question, is equal to 90. So then all we have to do is divide both sides by 2, and that gives us 45. So that is our equilibrium quantity. We have just one seller in the market choosing quantity and choosing price, which is the second part of this question. So we're asked to find the price that firm A should choose. So all we have to do is take the demand curve, which is P is equal to 100 minus Q, and plug in 45. That gives us that the equilibrium price is equal to 55. Okay. So we're all set here. The third part of this question is about profit. So we want to calculate the profit that this monopolist is generating. So profit is just total revenue minus total cost. So our total revenue is just price times quantity. And our total cost here, so we have a constant marginal cost curve with 0 fixed costs. So we just take the marginal cost and we multiply it by Q. Okay, so we have all these numbers. All we have to do is plug this in. We have a price of 55. Well, actually, I'm going to use a trick here. We have Q, which is multiplied both by P and by MC. So we know Q is 45, and we know on the inside that's 55 minus 10, which comes out to be 45 squared. So that's our profit. Okay. And the next part of this question is where things get interesting. So it turns out the commerce branch of the Ministry of Magic has been paying attention to this firm A and its stranglehold on the market. So the Ministry of Magic breaks up this company into two separate firms. And this is something that's often talked about in these sort of natural monopoly markets. Sometimes when we see close to monopolies living out in the wild, the government comes in and regulates. This happened in the telecom market quite a few decades quite a few decades earlier. And that's what gave us the telecom markets, the telecom companies we have today. So like AT&T, Verizon, Sprint. And what we're asked to do in this question is sort of discuss what happens in this market. So we're going to look at profits and quantities after a breakup. Just sort of observe what happens in response to this type of policy. It's a type of policy that we haven't modeled explicitly, but one that we have the tools for. So we're going to do it here. And all the tools we need are tools we've already developed. So what we do is, so we're asked to find the Nash equilibrium quantity of A supplied by B. So we've broken A into two companies, B and C, and we're asked to solve this just for B. So the first thing to realize is that this is symmetric. The marginal revenues are symmetric, and the marginal cost is also symmetric at 10. So all we have to do is solve MR equal MC. And let's do this for B. But it doesn't actually matter. Because this is symmetric, we solve for one, we get both. So MR is 100 minus 2QB minus QC. And we set that equal to 10, which is the marginal cost. And then all we do from here is solve for QB. So that's 2. I'm just flipping. I can just rewrite this actually. So we have 2 QB is equal to 90 minus QC. And then we'll just divide both sides by 2. So we have QB is equal to 45 minus 1/2 QC. Okay. And because this is symmetric, we can do this since we've solved for the best response function here, we can just write down the best response function for C, which is just swapping the subscripts. Okay. So then to find the Nash equilibrium quantity for B, all we have to do is plug in QC into QC and then solve. So let's write this over here. So we have 45 minus 1/2 times 45 minus 1/2 QB. So this means we can just expand. We get 45 over 2 plus 1/4 QB. So this means we have 3 over 4 QB is equal to 45 over 2. Okay, and we get some cancellation. giving us QB is equal to 45 over 3 times 2. So let's just simplify this. This is 90 over 3. And we'll do one more simplification here. We get QB is equal to 30. Put a box around it. Okay. And because we know this is symmetric, we also know this is QC, even though we're not explicitly asked for it. Okay, so the post-breakup market equilibrium quantity is just the sum of the two quantities. So our Q star is just QB plus QC, which is just 2 times either one of them, which is just 60. Okay, so we found the equilibrium quantity in this market, and we're asked to check it against the equilibrium quantity for the monopolist. So we went from 1 firm to 2 firms, and it looks like we went from 45 to 60. So let's just write this down. The equilibrium quantity post breakup is greater. Okay. And no, I can't read my own handwriting sometimes. Is greater. Okay. That's better. A little bit. So the next thing to do is just find the post-breakup price, and all we have to do is plug the quantity into the demand curve, and that gives us a price of 40. And again, this is sort of better for consumers. The price is lower post breakup. Okay. And the last thing to do is find the total profit. So we want to find the profit for both firms and add them together and then compare. So let's just do this for one firm and then multiply by 2. So we have the profit for B, which is QB times the price minus marginal cost. So the quantity here for a single firm is 30. The price is 40, and the marginal cost is 10. So this comes out to be 30 squared. So the profit in the market is 2 times 30 squared. Okay, and then so maybe we'll put a hat on this. Before, with the monopoly, we had 45 squared. So this is the point where I run to a calculator. And my expectation here is that the profit for the two firms is greater. So I'm going to plug 2 times 30 squared into a calculator and subtract 45 times 45. And this turns out to be negative. So the profit for the monopolist is greater than the profit for the two firms. And just sort of thinking through the intuition here, thinking through when we discussed collusion and cartels, this makes a lot of sense. The profit for the single firm being greater means that there's some incentive for these two firms, A and B, to collude and behave like monopolists and then split their profits. And so that's exactly what we found here. So this is generally good for consumers, this breakup, at least with a structure, a cost structure like what we're given. The prices have gone down, and the quantity in equilibrium has gone up relative to the pre-breakup market structure. Okay, so we haven't discussed welfare, but that's definitely something we could do if we were asked. Okay, so we'll leave it there. This is the parts of MiniExam 6 demo. I will see you all in class.